It began with silence. Not the kind of silence you notice in a quiet room, but a deeper, darker silence, the kind that wraps itself around the edges of space, beyond the orbit of the last known planet, where the sun is little more than a cold shimmer. Out there, at the distant rim of our solar system, Neptune floats like a silent sentinel, blue, vast, and long forgotten. For decades, it has remained untouched by time, cloaked in cold methane clouds and shrouded in mystery. We rarely look there. We barely understand it. But then, something happened. The James Webb Space Telescope, the most powerful eye humanity has ever turned toward the cosmos, saw something it was never meant to see. It was in the middle of a routine observation, nothing out of the ordinary. Webb was not even looking for catastrophe. It was merely scheduled to glance toward Neptune's southern hemisphere, to track its shimmering clouds, to watch its peculiar magnetic field twist and dance, to gather quiet data. But then came the burst. It was like a flare in the dark, a sudden, violent pulse of infrared radiation that screamed across Webb's sensors, so sharp and unexpected that it sent a ripple through the hearts of the astronomers watching. Neptune, a world colder than any place on Earth, had just lit up, not metaphorically, literally. And the flare was only the beginning. In those first few moments, confusion reigned. This wasn't how Neptune behaved. It didn't shine like this. It didn't erupt. Webb's data revealed a massive spike in thermal energy coming from the southern atmosphere, a hot spot where there should have been icy stillness. And then came the visual, a disruption, a gash across the clouds, a swirling wound in the methane veil that told a story no one wanted to believe. Something had hit Neptune. It wasn't weather. It wasn't internal activity. This was no storm brewing from within the planet. This was something foreign, something vast, slamming into Neptune's atmosphere with unspeakable force. Webb's spectral analysis began piecing the story together. A celestial body, perhaps 30 to 50 kilometers wide, about the size of a city, had collided with the ice giant. Not a comet, not a flake of debris. This was something big, something ancient. A ghost from the outer dark. No one saw it coming. The ice giants, Neptune and Uranus, have always been the loneliest planets. Too far, too cold, too faint. Even the mighty Voyager missions barely scratched their surface. But now, for the first time in decades, Neptune was the center of attention. It had been struck by a rogue wanderer from the edge of existence, and the scars were everywhere. There was no crater. Neptune has no hard surface to scar, but the aftermath rippled across its vast sky. Shock waves spiraled outward from the impact site, tearing through cloud bands at supersonic speeds. Webb sensors picked up the distortion in the planet's faint, ghostly ring system. A world that had remained static in our imaginations was now shaking from the inside out. The flare didn't fade quickly. For days, particulate debris hovered in Neptune's upper atmosphere, forming a thin, ghostly arc that shimmered in both visible and infrared light. It was likely all that remained of the object that had struck, a powder of ices and rock, the bones of a small Kuiper Belt object dislodged by gravity, now vaporized in Neptune's skies. The implications were staggering. If a massive body like this could strike Neptune without warning, what else might be drifting out there, just beyond the reach of our telescopes? How many of these icy beasts, frozen for eons, are still roaming the void? There was another layer to the terror. Neptune didn't just react on the surface. Its magnetic field, already one of the strangest in the solar system, tilted and unpredictable, suddenly fluctuated. The flux of charged particles around the planet shifted, indicating deep internal disturbances. Whatever struck Neptune didn't just leave a mark. It reached deep, rattling the mechanisms of the planet's core. And all of it happened quietly. No alarm, no warning. Just a flash in the dark, caught only because Webb happened to be watching at the right moment. Had it looked away, we might never have known. That silence, the silence after the impact, after the flare faded, after Neptune's clouds began to churn again, was deafening, because it reminded us how fragile our awareness truly is, because it showed us that the outer solar system is not the frozen graveyard we once believed, because it whispered something we've tried to ignore. The cosmos is not done with us, and now every eye is turning toward Neptune. Scientists around the world are scrambling to point their instruments skyward. The Hubble Space Telescope is shifting its schedule. Ground-based observatories in Chile, in Hawaii, in the frigid deserts and dry mountaintops of Earth are adjusting their gaze. Something happened on Neptune, and no one can look away. But the question lingers, unanswered, unsettling. What exactly struck Neptune? And is it the first or just the beginning? The more data poured in from the James Webb Space Telescope, the more the mystery grew. Neptune had been wounded, this much was certain. But as scientists began to analyze the layers of this cosmic event, it became clear that this wasn't just an isolated impact. It was a revelation, a tear in the veil of our assumptions, a message from the forgotten edges of our solar system. The first thing they noticed was the light. Neptune, normally one of the coldest, dimmest planets in the solar system, was now glowing, fever bright in Webb's infrared eyes. A region in its southern hemisphere, once so stable and frozen it barely flickered over years of observation, had transformed overnight into a glaring thermal anomaly. Temperatures had spiked. The atmosphere had been stirred. The planet's very energy signature had changed. What struck scientists the most wasn't just the heat, but the way the energy moved. Shock waves didn't stay local. They propagated across vast latitudes, rolling along jet streams and disrupting weather patterns that had held steady for decades. Neptune's high-altitude clouds, which typically move faster than any others in the solar system, suddenly shifted course. There were changes in their velocity, in their structure, in their rhythm. It was as if the planet was recalibrating itself. And then there was the debris. Webb had captured a cloud of particulate matter suspended in Neptune's upper atmosphere, a faint, hazy arc that shimmered and danced across multiple wavelengths. It wasn't just beautiful, it was haunting. This arc, scientists believe, was the final trace of the impactor, a rocky, icy body possibly dislodged from the Kuiper Belt, our solar system's twilight zone. That's what terrified planetary scientists the most. The Kuiper Belt is supposed to be a quiet place now. It's where Pluto lives, and thousands of other frozen bodies, slow-moving, ancient, drifting in the sun's farthest shadows. But this impact proved that the Kuiper Belt isn't as settled as we thought. Something had stirred it. Something had knocked this body loose and sent it on a death spiral straight into Neptune's heart. And no one knows what that something is. Was it a slow gravitational nudge from Neptune itself? A chain reaction of tiny interactions over centuries? Or was there another unseen body lurking in the dark, a larger mass disturbing the fragile balance of objects beyond our view? And if something disturbed one Kuiper Belt object, how many others are out there dislodged, invisible, waiting? Webb's instruments captured something else. Traces of new chemicals in Neptune's atmosphere, hydrocarbons and nitrogen compounds, rising in concentrations never seen before. The heat of the impact likely catalyzed chemical reactions deep in the cloud layers, dredging up ancient elements or fusing new ones from the shock. Some of these compounds were eerily familiar, found in the atmospheres of distant exoplanets. For scientists, it was like holding a mirror up to worlds far beyond our own. Neptune had become an unexpected laboratory for studying what happens when icy atmospheres collide with chaos. And all the while, Neptune's magnetic field continued to pulse with strange energy. Normally already chaotic, Tilted sideways compared to the planet's spin, the field now showed fluctuations that couldn't be fully explained. It was as if something in the deep layers of the planet, the places we cannot see, cannot touch, had shifted. That magnetic turmoil could last for weeks, or years, or it might mark the beginning of a longer, deeper transformation. This wasn't just a fleeting scar. This was a planetary event, the kind that alters the evolution of a world. And for us, standing billions of kilometers away, watching from the safety of our tiny blue home, it was a sobering reminder. The solar system is not asleep. It moves. It stirs. It strikes. And yet, if the James Webb Space Telescope hadn't been looking, we would have missed it. That's what keeps echoing in the minds of every scientist involved. If Webb had pointed even slightly off course, if its schedule had shifted, if its instruments hadn't been tuned just right, this whole moment would have passed us by. Neptune would still be glowing out there in silence, still digesting the violence, and we'd have no idea. The truth is, our observational tools, though more advanced than ever, are still astonishingly limited. JWST wasn't even designed for this kind of work. Its primary mission was to peer into the distant past, to look at galaxies billions of light years away, to search for the chemical whispers of life on exoplanets. And yet, it captured this, the most dramatic planetary impact in living memory, almost by accident. That's the part that shakes you. Not just what happened, but how close we came to never knowing. Now the scientific world is mobilizing. New Neptune observation campaigns are being scheduled. Hubble is turning its eye toward the planet. Ground-based observatories are calibrating their instruments to study the aftermath in visible and ultraviolet light. The European Southern Observatory is planning spectrographic readings to track atmospheric changes, and every new image, every sliver of data, brings fresh awe and new questions. Because this wasn't just about Neptune. This was a wake-up call for Earth. What if it had been us? What if a similar-sized object had been barreling toward our planet? Unlike Neptune, we don't have thick methane clouds to absorb the shock. We don't have a gaseous cushion to soften the blow. An object 50 kilometers wide striking Earth would be an extinction-level event, civilization ending, and yet we barely saw it coming. Not because it was headed for us, but because we weren't even looking in the right place. This impact has forced planetary defense experts to revisit everything: our tracking systems, our assumptions about distant object behavior, even our models of solar system stability. If something this massive can drift inward from the edge of the void and collide with a planet without a single warning signal, how safe are we, really? We often talk about the vastness of space as a comfort, as if distance equals safety. But the Neptune impact reminded us that space is not a wall, it's a highway. Objects move, forces shift, gravity whispers in the dark, and sometimes something answers back. In the weeks that followed, Neptune remained under a silent spotlight. A planet once shrouded in blue silence now pulsed with invisible aftershocks. Astronomers across the globe kept watching, kept measuring, as though the planet might whisper something back. But Neptune, like the rest of the cosmos, doesn't speak in words. It speaks in movement, in light, in heat, in changes so subtle only the most sensitive instruments could feel them. And still, the story deepened. There were new developments. Subtle variations in the motion of Neptune's faint ring system began to appear. These delicate, dusty arcs, unlike the bold rings of Saturn, usually hovered just on the edge of visibility. But in the aftermath of the collision, they flickered. Their structure wavered, their brightness shifted. Some arcs seemed denser, others almost torn. Scientists believe the shock waves that rippled through Neptune's atmosphere had extended beyond it, shaking the very particles that orbit the planet. Tiny flecks of matter, possibly stirred up or even added by the impact, now drifted like smoke, lit by a distant sun. And the winds, they were changing. Neptune is famous for its ferocious winds, the fastest in the solar system, reaching speeds over 1,200 miles per hour. But now, something was different. In some regions, the jets had accelerated. In others, they had fractured, splitting into turbulent shears. It was as though the entire atmospheric machine had been rewired by a sudden burst of external energy. The weather system of an entire world had blinked, and in that blink, rearranged itself. These changes may persist for months, or for years, maybe even decades, and the data pouring in from telescopes, both space-based and ground-based, is being combed for every clue. But even as scientists analyze and model, there's a growing sense that we've entered a new phase in planetary science. This event wasn't just an isolated impact, it was a door opening, a realization. For so long, the outer planets were treated as relics, frozen behemoths drifting in quiet orbits. But this impact shattered that image. It reminded us that the solar system is still alive, that it breathes, that it hurts, that even at its furthest corners, change happens fast and without warning. And that realization has lit a fire beneath a new wave of curiosity. Uranus, Neptune's cousin in size and composition, has long been ignored. Its extreme axial tilt, bland appearance, and lack of recent missions left it on the sidelines. But now scientists are turning back to it with fresh eyes. If Neptune, once thought stable, can become the stage for such violent drama, then what secrets might Uranus be hiding? The case for a dedicated mission to the ice giants has never been stronger. The urge to send a new spacecraft, to fly past, to orbit, to observe these enigmatic worlds up close is growing, because now we know what we might be missing. But beyond science and research, beyond data and diagrams, this story touches something deeper. It touches the part of us that looks up at the night sky and wonders what else is out there, not just in the abstract sense, not just galaxies far away, but here, in our own cosmic neighborhood. We often forget how little we know about the very solar system we live in. The collision on Neptune reminded us of that, reminded us how small we are, how easily change can come, how something that was drifting silently in the dark for millions of years could, one day, intersect fate with a world. And that brings us back to Earth. What happened on Neptune was, in many ways, a gift. A cosmic message delivered in the language of dust and fire. It taught us about impacts and atmospheric chemistry, about magnetic field disruptions and ring perturbations. But more than that, it reminded us of our fragility, of our place in the solar system. That just as Neptune was struck without warning, so too could we be. And this is not fear-mongering, it's perspective. Because if a telescope designed to gaze into the first light of the universe can turn and catch a planet in the act of transformation, then maybe, just maybe, we're beginning to see things differently. Maybe we're entering an age where our view of the solar system is not distant, but intimate, where we stop seeing these planets as far-off spheres of mystery and start seeing them as part of a living, breathing system of motion and consequence. And it's not just about looking outward. It's about readiness, about vision, about realizing that every collision, every ripple, every plume of dust in the cold corners of our system might hold the key to understanding not just what could happen out there, but what could one day happen here. The scientific community is shifting. Missions are being reprioritized, observation strategies reimagined. There's a renewed sense of urgency. Not panic, but purpose. We've been given a front row seat to a rare and powerful event, and with it, a responsibility to listen, to learn, and to prepare. Because the next time an object breaks free from the Kuiper Belt, or hurtles in from the void, it might not be Neptune that catches it. It might be us. And as we gaze deeper into that cold blue world, still glowing faintly from the wound it sustained, we are left with awe. Not the kind that fades, but the kind that lingers. The kind that reminds us that the universe, for all its silence, is always speaking. We just need to keep watching.